So to wrap up this first section, I want to draw your attention to the fact that in both the case of the latch and a flip-flop, we were only able to store 1 bit of information. 1 bit is certainly more useful than 0 bits of information, but in computers we actually tend to talk about things in larger groups of bits, such as bytes or words, which is 32 or 64 bits depending on your architecture. And so we need to be able to have a way of storing multiple bits, not just 1 bit at a time, but lots of bits together as a group. In order to accomplish that, we have what's called a register. And so a register looks something kind of like this. You see that a register consists of a series of D flip-flops. We just talked about D flip-flops in the previous video, right? And I have a whole bunch of bits coming in, and then the same number of bits coming out. The clock signal, you can see, is shared by all of these D flip-flops. So all of these D flip-flops are on the same clock cycle, which means that they are going to be synchronized and update at the same time. We spent a lot of time talking about that in the previous video, why that's important. And so here I see 3 D flip-flops. That means that this register is capable of storing 3 bits of information. So I have a 3-bit register. If I want larger configurations of bits, all I need to do is add additional D flip-flops and I can create larger registers.